Welcome back to another video that is probably never going to be uploaded, and also to a series that nobody asked for. So the thing is, I really like creating videos. Not specifically creating videos, I really enjoy making videos in a sense that I just do whatever software engineering stuff I like to do and then I just record it. But the thing is, these videos are just way too long and nobody's going to watch it. So I probably will never even upload these. But anyways, since we are here, might as well do it, right? It's something I enjoy. Honestly, it's pretty dang fun. The reason it's being fun because when I just read and do stuff by myself, I just don't generally talk. I just type, Google stuff, ChatGPT stuff, all those stuff, right? But when I'm actually creating a video, I'm forced to talk, and that's a pretty damn good thing. A, because I'm really talkative, I just like to talk. B, actually me thinking out loud really, I believe, helped me in some sort of manner. I don't know, it's something, maybe it helps my English be better because English is not my first language, or it just make my personality a little bit more extroverted. I'm not sure. It is what it is, right? I like it, I will do it. But anyways, so today's topic is something which I have been looking for a long time, but I never really gotten around it. It's called MapReduce. So it's not the javascript.map.reduce, that's not we are talking about. So I'm not sure what MapReduce actually is in this context of distributed system, but I'm really curious about it because for a long time I've been thinking and I've probably heard a lot of thing around MapReduce when it's come to distributed system, and actually I don't even know the introduction about MapReduce. And also not to mention that uh, in one of our products we actually use Apache Hadoop, and I believe it uses MapReduce internally to do some computation, but that's the maximum knowledge I have about MapReduce. Anyways, I think it's a good thing to learn about. It's probably a long, I mean, it's a long paper. It's not that long, I guess. It's only 13 pages, but it is what it is, right? Okay. So MapReduce, simplify data processing on large clusters. Okay, yeah, also before we start, it's a bit of disclaimer. I'm not sure what to actually do in this video, right? Except for reading it and just thinking out loud. And I honestly can't say what you should be looking for in this as a value, except you going through this with me and learning what MapReduce is. Also, like I said, it's not a video I will upload. There's a lot of high chances that I won't upload, but I just like creating this. Okay, so Jeffrey Dean and Sanjay Khemawat. Okay, smart people, way smarter than me, I guess. So that's an abstract. So MapReduce is a programming language and associated implementation for processing and generating large dataset. Users specify a map function that processes a key value pair to generate a set of intermediate key value, and reduce function that merges all the intermediate value associated with same intermediate key. Okay, many people, many real-world tasks are expressible in this model as shown in the paper. Okay. So I think this is symbol. I mean, this paragraph at least is similar to what MapReduce is in JavaScript. So it says that user specifies a map function that processes a key value pair. So generally, I'm just going to take a JavaScript analogy. It's not that good. It's probably pretty bad analogy, but it is what it is. So in JavaScript, we have map.map function, which basically iterates through a array, right? An array, like in for loop, we can some sort of vaguely think of array as a key value pair, which absolutely an array is not a key value pair, but we can think of it as like that. And yes, so user specify a map function that processes key value pair to generate a set of intermediate key and value pairs. So okay, so yeah, so we take a key value pair and map is a function which runs on that key value pair to generate an intermediate key value pair. Okay, and reduce function that merges all the value associated with the same intermediate key. Interesting. Honestly, the first part I'm confused. Wait, really? So MapReduce is a programming language and associated implementation for processing and generating large dataset. Makes sense. Specify the map function that processes a key value pair to generate a set of intermediate key value pairs. Okay, copying. Wait, what? Why can't I copy it? Yeah. So let's just say this is the map, right? It's a function. Or maybe let's not even do it like this. So map is a function, right? Which takes key and value as an input, I guess, and it outputs the intermediate key value pairs. Okay, so it clearly says that map is a function that processes a key value pair and generates a set of intermediate key value pairs. So I'm assuming, okay, I think I got it. So yeah, so as an input, so we take a key value pair, push it to map function. Okay, and it generates a set of key value pairs, right? Not okay. Yeah, I guess that makes sense. Okay, let's make it a little bit bigger. Okay, and that's not even, that's intermediate, right? Okay, that's annoying to actually align. Many real world. Okay, so and the reduce function that merges all the values associated with same intermediate key. Okay, I think I got it now. So if I take this, not this, if I do this, and this means we will have a reduce function, I guess, which will take this set of intermediate key values and then provide this, and then merges all the intermediate key value with the same intermediate key, and obviously it will produce a value, right? So it will produce a value, but it will merge on the basis of same intermediate keys. What's the spelling of intermediate? Okay, yep, I can actually make this bigger. Yeah, okay, I think that makes sense. So if I'm gonna make this a little bit more organized, so this is what we have learned in the first section, I guess. We have a key value pair, we run it to a map function. It generates the intermediate set of key value pairs. It's essential to note that I think it's a lot of pairs, right? So it says that it key value pairs, and then map function reduces all it in a single value associated with same key. Makes sense, right? I think essentially this is what it is. You know what, actually, how do I make them single entity? Is this it? No, never mind, leave it. Okay, I guess how much, 10 minutes in and only first para has been ready. Yeah, good speed. Anyways, The program written in this functional style are automatically parallelized and executed on large cluster of commodity machines. Okay, so in very easy terms, basically VMs. The runtime system takes care of the details of partitioning the input data, scheduling the program execution across a set of machines, handling machine failures, and managing the required intermediate communication. This allows programmers without any experience with parallel and distributed system to easily utilize the resources of the large distributed system. Okay, this paragraph was relatively easier. So all in all they are saying is that basically when we write, uh, when we use MapReduce, it essentially is an abstraction which internally will take whatever we have given to the MapReduce interface. It will partition it, throw it across multiple instances, multiple machine. It will schedule the program execution. It will handle the failures. It will basically do all the intercommunication stuff. Basically, it will take care of everything and anything that is required for the parallelism and for this to work on a distributed system. And the program doesn't need to know, right? They just have to call this interface of MapReduce and it will essentially work. So my question is, does the same thing happen when I use javascript.map.reduce? Just a question. I don't think so. I don't think so. But I don't know why I'm thinking of JavaScript all the time. Too much vibe coding nowadays. Okay. Our implementation of MapReduce runs on a large cluster of commodity machine and is highly scalable. Okay. So wait, I'm confused. MapReduce is a programming model and associated implementation for processing and generating large datasets. So it says that our implementation of MapReduce runs on a large-scale cluster commodity, highly scalable. Okay, so I thought this was the first paper on MapReduce. I was wrong. So they are saying that their implementation of MapReduce. So this means essentially MapReduce was a concept. Okay, it makes sense what it was a concept because MapReduce internally is technically a functional programming concept as far as I know, and functional programming probably existed a lot longer before this paper. So okay, so this is not a MapReduce paper. First of all, it's the implementation of what Google has created for MapReduce to work for their system. Okay. A typical MapReduce computation processes many terabytes of data on thousands of machines. Programmers find the system easy to use. Hundreds of MapReduce programs have been implemented. Okay, so I thought this was the first MapReduce actual paper. Okay, turns out it was just not it. Okay, you learn and grow, I guess. Hundred of MapReduce problems has been implemented and upward of 1,000 MapReduce jobs are executed. Wait, what? So okay, so I was wrong. This I thought they said that hundred of MapReduce programs have been implemented before this paper was published, which is technically true, but it was in Google ecosystem. So I'm pretty damn sure that this is not the first paper of MapReduce. Uh, I think MapReduce itself was a concept before this paper. It's just that it is the one of the big papers of MapReduce on such a distributed large system. Okay, wait, why I'm thinking? Let's ChatGPT it, right? Why I'm thinking so much? What was the name of the paper again? Mm-hmm. Is this the first MapReduce paper ever, or if was the MapReduce actually introduced for, and why is this paper famous so much? Okay, let's think. Let's see what it is. This wasn't the brand new. Okay, makes sense. The idea wasn't brand new, but this paper is the first time MapReduce was clearly defined, name, and shown to. Okay, yeah. So basically, okay. So like I said, it was not the first time that this concept was introduced. I guess functional programs contain map and reduce, but I guess this paper was the first time when it was just put it to work on such a big scale because Google worked on it. Was it the first? Okay, yes and no, not the first time concept existed before Google precursor existed. Yeah, like I said, map, functional program, map and reduce. Okay, okay. Where is this SQL group by? Okay, so SQL and group by. Yeah, I guess it makes sense. It makes sense. We can think of group by, I guess in loose terms, as map reduce because we have key and we have values. What group by does, it takes all the rows with essentially same criteria, group it, and then work on it. So maybe we do some aggregation, so it will take some on it. So basically the grouping itself will be a map kind of thing, and then we will do the aggregation. It's a reduce kind of thing. So loosely we can, I think we can make an analogy of group by as map reduce, group by aggregation pipeline things as map reduce. Okay, and then that means that Mongo aggregation pipeline itself could be a map reduce. Let me think, because but yeah, we run on, but I'm not sure, right? Because it clearly says that for map reduce to work, we have to give a key value pair. It will reduce a intermediate key value pairs. Does aggregation pipeline does that? Not sure. Wait, group by does that? So we have a key value. Okay, yeah. So basically, we take a key and value. Basically, we take a criteria. We do the group by on criteria. It will take a lot of rows, and then we run some function on it. So basically, that's a reduce. Okay, in loose terms, a group by could be thought of as a map reduce. I guess then does the aggregation pipeline, because in aggregation pipeline we also have group by and all those stuff. Yeah. Okay. Uh, II is basically intermediate result data processing pipeline, large scale indexing system. You already use MapReduce. Okay. So the idea was there. First to introduce MapReduce as a system, what it was a new MapReduce as a programming model. Okay. Built a general purpose distributed system around it. Yeah. Okay. So the model, sorry. So they defined MapReduce from a concept. They defined it a model. Okay. And created a distributed system around it. It fault tolerance, scheduling, data partitioning, load balancing, proved it at Google scale, thousands of machines. Okay. I mean, that kind of cool. That's kind of cool. Like, they did all that stuff. Pretty dang awesome. That combination was new. It wasn't just map plus reduce, it was map plus reduce plus automatic distributed execution at scale. Yeah, I guess that's why they said at the paper that it's just a basically abstraction and the programmer has never to worry about it, because they just will call this map reduce, and I guess that internal functioning will be taken care of, because in the end that's what abstraction is. I can't say it. Okay. Okay, I'm not sure which year paper it is. Okay, I also forgot to read. So yeah, so MapReduce at 2004 is an original paper, right? And 2008 is expanded polished version at CSCM. Which version I'm actually studying, I'm not sure. I just got this from Google's official website, so I'm not sure which actually year it is. But I mean, anyways, even if it's expanded and polished version, that's good for us. whereas it democratized large-scale distributed computing. Before MapReduce, writing distributed system required deep expertise. It probably, as of now, does also require a lot of expertise. So after MapReduce, write two functions, the system handles the rest. Makes sense. That was mind blowing at that time. At the time, it is still mind blowing at this time as well. I mean, people who knows MapReduce wouldn't be surprised, but for people like me, it's pretty damn good. It showed how Google actually worked. This was one of the first time Google said, "Here's how we process petabyte of data." That had a huge credibility and influence. Makes sense because I mean, people still like to quote MapReduce today as well. Really, and when I was searching through different research paper I want to read, MapReduce was one of the really first recommendation I've pretty much gotten. Okay, I mean half hour in this video and all I've read is two paragraphs. Mm-hmm. Oh, three paragraphs. Very nice. Oh, with this, oh why? To appear in Odyssey 2004. Okay, so that's an appear. That's an original paper. Good to hear. Good to read. Yeah, yeah. Also, at this speed, I don't know. Like, it will take me probably 500 hours to deal with this. Anyways, over the over the past 5 years, the author and many others at Google have implemented hundreds of special purpose computation that process large amount of raw data such as crawl document, web request logs, etc. to compute various kind of derived data such as inverted indices, various representation of the large of the graph structure of web documents, summaries of the number of pages crawled per host. Okay, that went through my head straight up, not gonna lie. So over the past 5 years, the author and many others at Google have implemented hundreds of special purpose computation that process large amount of raw data, such as crawl documents, crawlers make sense, web request log, okay, etc. to compute various kind of derived data such as inverted indices, various representation of graph structure of web document, summaries of the number of pages crawled per host, a set of most frequent queries in given day. Okay, we are here. Most such computation are conceptually straightforward. However, the input data is usually large and computation have to be distributed across hundreds or thousands of machines in order to finish in reasonable amount of time. The issue of how the issues of how to parallelize the computation, distribute the data, and handle failure conspires to obscure the original simple computation with large amount of complex code to deal with issues. Okay, I think now I understood it. So basically, what the author is trying to say is that mm, basically Google in like last 5 years from 2004, it means from probably 1999, I guess. Yeah. Anyway, and sometime Google actually took a large amount of data, including crawl documents, web request logs, and they tried to derive a lot of derived data from it, right? So they had a lot of data, some sort of complex data, some in graph form, some in other form, and they had to derive some other results out of it. So I guess these results that they want are pretty straightforward, right? So if I was just given a single individual input, let's just say a single crawl document or a single request log, not single request, maybe like some small batch of crawl document or some sort small batch of request log, a single relatively complex algorithm would have been needed, and in like some time the algorithm would have ran on the inputs and would have given us the output. I think that's what they said, right? And the computation itself would have been relatively complex, but yeah, it would have been doable. But since they have such a high number of load, that the input data is so large that they have to actually had to parallelize it to ensure that fits in the reasonable amount of time, and that parallelization mechanism probably is way harder than the algorithm that ran on that ran on some of the documents itself. Okay, makes sense. I mean, this is our day-to-day life, right? So the moment we have multi-threading, sometimes the process inside the multi-threading itself is trivial, but ensuring that multi-threading works perfectly and there's synchronization and all those stuff required is pretty hard. Also, it's not like I did multi-threading a lot, but yeah, doing yeah, okay. As a reaction to this complexity, we designed a new abstraction. Okay, that's an abstraction code. I know. Oops, right. We designed a new abstraction that allows us to express the computation we are trying to perform but hides the messy details of parallelization, fault tolerance, data distribution, and load balancing library. Yes, so that's the parallelization is not the only issue, right? The moment we have parallelization and we have thousands of machine, fault tolerance is also required. I mean, sorry, I can only assume like fault tolerance would be really damn high in this case because we have such high number of machines. Data distribution, obviously, if we have to parallelize the data, we have to distribute the data. And load balancing, okay, yeah, because we have so many nodes, essentially we have to load balance the thing. Okay, yeah, so this is basically now a distributed problem. It's a system design problem. Very nice. Our abstraction is inspired by the MapReduce primitive represented in Lisp and many other functional languages. Got it. We realize that most of our computation involves applying a map operator to each logical record in our input in order to compute a set of intermediate key values and then applying a reduce to all the values that share the same key in order to combine the derived data appropriately. Makes sense, makes sense. I mean, it would have been pretty damn hard. I mean, I can only imagine like how hard would it have been for them to actually implement this, and before even implementation think like, okay, so we need map uh, we need map and reduce most of the time, so let's make it abstraction over a distributed system. It would have been that much easier for them. I mean, I would have not been able to do that. Our use of functional model with user specified map and reduce allow us to parallelize large computation easily and to use re-execution as primary mechanism for fault tolerance. Okay, I did not get this line. Use re-execution. Oh, okay. Now I got it. The moment the paper got disaligned from the screen, like something clicked. Okay, so they are saying that okay. So basically, we provide a MapReduce algorithm. It takes it as an input and it paralyze the data. Does the large computation is relatively easier and basically re-execution as the primary mechanism for fault run. So let's just say there is a faulty node, right? So instead of trying to make it better and do all the shenanigans, whenever whenever some other node is finished and it has have some bandwidth or it is ideally idle, we just rerun it again. We just do the re-execution on that node, and that's how basically fault tolerance is going to be mitigated, right? That's the primary mechanism. So just rerunning or re-executing the process in the other nodes, or maybe I guess ideally the idle nodes. The majority contribution of this work is a simple and powerful interface that enables automatic parallelization and distribution of large-scale compute combined with an implementation of this interface that achieve high performance in large cluster of commodity PCs. Then again, the same thing. Easy abstraction and such a powerful interface that enables automatically parallelization and distribution across large-scale commodity PC. Commodity PC is basically your day-to-day consumer PC, right? Maybe not day-to-day, but consumer PCs, right? Right. Okay, commodity PCs should be different, right? Okay, yeah. Like, it's not consumer PC, it's different. Section 2 describes the basic programming language. It gives several examples. Section 3 describes the implementation of MapReduce interface tailored toward a cluster-based computation environment. Section 4. Why does it get de-aligned? Section 4 describes the several refinement of programming model and that we have found useful. Section 5 is performance measurement of our implementation for variety of tasks. Section 6 explored the use of MapReduce within Google, including our experience in it using as a basis for the rewrite of our production indexing system. Section 7 reduces the later and future work. Okay, I just speed run through it that. Okay, this was easier because I didn't have to understand anything because we are just going to a section synopsis. Okay, so this will be pretty interesting, and it will be pretty interesting, but I think this is a good place to actually end the video. Anyways, it's been a fun ride actually learning what MapReduce is. Essentially, it's not that complicated in theory, it's just a pure, simple, powerful abstraction and interface that requires some input, and it does all the parallelization and distributed system magic in the backend that user doesn't need to know about. Essentially, that is it. Obviously, like I said, not like I said, like people said, the devil is in the details. I'm sure it will be really hard to implement this, like really super hard. But that anyways, like the synopsis itself is pretty damn simple to understand. Okay, that's it for the video, and I will see you in the next one. Oh yeah, by the way, have a good day, good night wherever you are, and stay healthy. Bye.